should be page 5 in your math notebook, so you can put a 5 at the top. The objective for today is that students will be able to solve one-step equations and justify the steps. So first, in order to solve one-step equations, it's really important that we understand inverse operations. Those are operations that undo each other. So for example, subtraction undoes addition, or they're opposites. Think about Elmo and Sesame Street, teaching you opposites, up versus down, left versus right. The opposite of multiplication is division. The opposite of squaring something is to take the square root. So more specifically, let's go ahead and state the inverse operations for each of these. So the opposite of adding 23 would be subtracting 23. The opposite of subtracting 18 would be to add 18. The opposite of multiplying by negative 15 would be to divide by negative 15. And the opposite of dividing by 8 would be to multiply by 8. Alright, so solving equations using inverse operations. Well, a mathematical sentence that contains an equal sign is an equation. So you guys probably already know that an equation has to have an equal sign. The goal of solving an equation is to isolate or get the variable by itself. So isolate the variable while maintaining the balance of the equation. What that means is basically what you do to one side, you have to do to the other. So if you add 18 on both sides of the equation, you have to do that to the other side of the equation as well. To do this, you need to undo what was done to the variable using inverse operations. So now that we've got the big picture, let's talk about the different properties you're going to see. The first one is the addition property of equality, which says if A equals B, then you can add the same thing on both sides. So if A equals B, then A plus C equals B plus C. In other words, adding a number to both sides of the equation doesn't change the balance. Then you have the subtraction property of equality, which says that you can subtract the same thing from both sides of an equation and it doesn't change the balance. So if A equals B, then you can subtract C from both sides and it keeps the balance. A lot of times you won't see subtraction property of equality written. It will actually be written as the addition property of equality, and so this can sometimes be interchangeable with the addition property of equality, so that's good to keep in mind. Next we have the multiplication property of equality, which says multiplying the same thing to both sides doesn't change the balance. So if you keep a look, you can multiply C on both sides and it keeps the balance. And then last we have the division property of equality, which says dividing the same number on both sides doesn't change the balance. And sometimes you'll see division written as multiplication because if you think about it, say I want to take the number 4 and divide it by 5. That's the same as taking 4 and multiplying by 1/5. So you can really rewrite division as multiplication. Alright, let's try some problems. So taking a look at example 1, first I want to find the variable that I'm trying to isolate. I'm trying to get y by itself. So I'm adding 3 to y. The opposite of adding 3 would be to subtract 3. I'm going to go ahead and draw a line down my equal sign. That's helpful to make sure that you balance everything. So if I subtract 3 on one side, I have to subtract 3 on the other side. So positive 3 minus 3 cancels out, leaving me with y equals 10 minus 3 is 7. And what property allows me to subtract the same thing on both sides? Well, that of course is the subtraction or addition property of equality. So there you go, y equals 7. And the last step, it's not an extra step, it's really the last step, is to check. So I'm going to go back to the original equation. Y plus 3 equals 10. And I'm going to plug in 7 and see if it gives me a true statement. So replacing y with 7, 7 plus 3 is 10, 10 equals 10, we're good to go. So make sure that you check your solution. If at any point during this video you feel like it's going too fast, you can always pause it, take a look at what you wrote down, and then continue watching. So that's the beauty of getting to watch a video. You can kind of play it at your own pace. So let's look at example 2. I'm going to want to isolate x. So right now I'm subtracting 7 from x. So the opposite would be to add 7. And whatever I do to one side, I have to do to the other. So the negative 7 plus 7 cancels out, leaving me with just x on the right. And negative 2 plus 7 is going to give me positive 5. The property that allowed me to add the same thing on both sides would be addition property of equality. And a lot of us will be tempted to do one more step and flip that around to say x equals 5. What property allows me to flip across an equal sign? That is the symmetric property. Not to be confused with commutative property. Commutative property says you can flip across addition or multiplication. Alright, last step we need to check. So I'm going to go back to the original problem, negative 2 equals. Instead of x, I'm going to put 5, since I believe that x is 5. And I'm going to make sure the left side equals the right side. So 5 minus 7 is negative 2. Negative 2 equals negative 2. So the solution is correct. Again, you can pause it if you need more time to copy this down. Alright, let's go ahead and flip over and look at the next example. So here we've got negative 121 equals negative 11a. So I want to get a by itself. Right now, the operation attaching negative 11 to a is multiplication. So the opposite would be to divide. And I'm going to bring that negative sign right along with it. Whatever's in front of a, I want to divide out. So dividing negative 11 on both sides leaves me with just a. And negative 121 over negative 11 is going to be positive 11. And that was the division or multiplication property of equality. And the last step, I'm going to go ahead and flip it. And what property was that? Very good. If you were thinking symmetric property, you were correct. Let's go ahead and check our answer. So I'm going to go back to the original problem, negative 121 equals negative 11. And I'm going to plug in the value for a. Make sure the left side equals the right side. So negative 121 equals negative 121. I got the correct answer. What happens if you check and you don't get the left side equals the right side? Well, that means you probably did something wrong and you need to go back and check your work. Maybe you forgot a negative, maybe you used the wrong inverse operation, so it's always good to go back and fix. Alright, let's look at our next problem. So here we've got g divided by negative 7. The opposite of dividing by negative 7, of course, would be to multiply by negative 7. I'm going to do that on both sides, which cancels out the denominator just like I wanted. And on the right, 7 times negative 7 is negative 49. Let's go ahead and check by plugging back into the original problem. So instead of g, I'm putting negative 49. And negative 49 over negative 7 is going to give me 7, which is exactly what I wanted. So we got the correct answer. Moving right along to example 5. This one sometimes trips us up because we've got a fraction being multiplied to our variable that we need to get by itself. So, anytime you need to get rid of a fraction, there's really two ways to think of it. One, doing it as a one-step equation, you flip the fraction, so you take the reciprocal. So in this case, the opposite of 3 over 4 would be 4 over 3. And you multiply that on both sides of the equation. So if you plug in your calculator 4 over 3 times 3 over 4, you're going to get 1, and that just cancels out to give you x. Go ahead and plug in 27 times 4/3, and that's going to give you confuse you, another way to think of it is, so here's our problem again. Think of this as 3 divided by 4. So first, get rid of your divided by 4. Well, what's the opposite of dividing by 4? Multiply by 4. So multiply both sides by 4, which will give me 3x equals 108. And then divide both sides by 3, and you will get 36. So that's another way to, so whichever way works for you, this way was the one-step method, and then here we kind of broke it down into 2 steps. First getting rid of the denominator, and then getting rid of the coefficient. So again, whatever way works for you. If you want to replay that to see either of those 2 methods, please feel free to do that. All right, let's look at example 6. It says to translate and solve. So 20 more than a number is 92. I like to take care of this part first, because I know is equals, so it's going to be equal to 92. All right, so 20 more than. More than, I know, is going to be plus. And it's kind of like less than in that it's written after your number. So it says 20 more than a number, I'm going to use x as my number, and then 20 more than that would be x plus 20. And now we're just going to go ahead and solve. So subtract 20 on both sides, and you'll get x equals 72. Of course, we want to go back and check that and make sure that 72 plus 20 is really 92, and it is 92 equals 92. We're good to go. And I totally forgot to write the properties the last couple problems. So let's go back and just talk about what property allows me to subtract the same thing on both sides. So that, of course, is the subtraction or addition property of equality. And then going back to example 5, multiplying the same thing on both sides would be the multiplication property of equality. And we can check that. Is 3/4 times 36 really equal to 27? Plug that in your calculator. It does give me 27 equals 27. So we're good to go. All right, again, feel free to replay any of those examples there. And at this point, you're going to go ahead and try your UU problems. Yes, you do have to write the property. Yes, you do need to check. And when you're finished with that, raise your hand and your teacher will come over and give you the appropriate color, and then you can start on finishing your packet.